Imagine a nuclear reactor small enough to fit in a shipping container, yet powerful enough to provide clean energy for an entire remote community. Meet the eVinci TEM Microreactor, an innovative concept from Westinghouse that could revolutionize the way we think about energy. This compact, scalable reactor offers a glimpse into a future where reliable, carbon-free energy is not only safe but also portable and easily deployable. The eVinci TEM Microreactor is designed for areas where traditional power solutions are not feasible, including remote communities, industrial sites, and even disaster recovery zones. Unlike conventional nuclear reactors, which require complex infrastructure and high-pressure water cooling, the eVinci TEM reactor is prefabricated and transportable, arriving on site in a standard shipping container. But how does the eVinci TEM Microreactor achieve such flexibility, and what makes it so safe? In this video, we'll explore its groundbreaking features, from passive safety systems and a long operational life to its capability to support sustainable industries like hydrogen production. Let's dive into the eVinci TEM Microreactor's innovative design and discover how this next-gen technology could shape the future of clean, reliable energy. The eVinci TEM Microreactor by Westinghouse is not your typical nuclear reactor. It's a micro-modular reactor, a compact, transportable unit that can be easily delivered and set up wherever reliable, clean energy is needed. Unlike traditional reactors, which require large infrastructure and constant oversight, the eVinci TEM Microreactor is designed to be low maintenance, scalable, and highly adaptable to various applications. One of the most impressive features of the eVinci TEM reactor is its modular, prefabricated design. It's fully assembled in the factory and then transported in standard shipping containers to the desired location. This plug-and-play setup enables fast and easy deployment in areas where traditional energy infrastructure is lacking. Whether it's powering a remote mining site, a military base, or a disaster recovery operation, the eVinci TEM Microreactor can be quickly deployed to provide a reliable power source without the need for extensive construction or a large footprint. The eVinci TEM Microreactor is specifically designed to be flexible and versatile. With its power output ranging from 200 kilowatts to 5 megawatts, it can meet the energy needs of small communities, industrial sites, and even high-demand applications like data centers. Because it's a modular system, multiple reactors can be combined if a larger power output is needed, making it a scalable solution for various energy demands. Furthermore, the reactor's compact size and low maintenance requirements make it ideal for remote and isolated locations. Traditional reactors require a lot of water and complex cooling systems, but the eVinci TEM reactor uses advanced heat pipe technology, which requires no water cooling and very little active management. This setup enables safe, reliable operation in areas where conventional nuclear reactors would be impractical or too costly to install. The eVinci TEM Microreactor isn't just a compact energy solution, it's also a clean one. As a zero-carbon source of power, it aligns with global efforts to reduce emissions and transition to more sustainable energy sources. By providing consistent, carbon-free energy to hard-to-reach locations, the eVinci TEM reactor has the potential to make a significant impact on reducing global carbon footprints. The eVinci TEM Microreactor stands out from traditional nuclear reactors thanks to several groundbreaking features. One of the most notable is its passive safety system. Traditional reactors require active cooling systems to prevent overheating, but the eVinci TEM reactor uses heat pipe technology and TRISO fuel to achieve passive cooling. This design is naturally safe, as it doesn't rely on external power or water-based cooling systems. If the reactor needs to cool down, the heat pipes distribute heat passively, eliminating the risk of overheating and significantly reducing the likelihood of a meltdown. The eVinci TEM Microreactor also uses TRISO tristructural isotropic fuel, a highly robust fuel type that is engineered to withstand extreme temperatures. TRISO fuel particles are encased in 3 layers of protective ceramic material, making it virtually impossible for radioactive materials to escape, even under extreme conditions. This fuel choice enhances the reactor's safety, reliability, and operational lifespan. Another remarkable feature of the eVinci TEM Microreactor is its long operational life. It's designed to operate for 8 or more years at full power without refueling, providing a consistent, long-term energy source with minimal maintenance. This extended operational period is especially valuable for remote or isolated locations where access to regular maintenance and refueling services might be limited. Fuel flexibility is another advantage of the eVinci TEM reactor. In addition to uranium, it can also use thorium as a fuel source, a more abundant and potentially safer alternative. Thorium produces less long-lived radioactive waste and can be sourced more widely. The reactor is also capable of using recycled nuclear waste from other reactors, making it an attractive option for countries looking to reduce their nuclear waste stockpiles. This versatility in fuel types allows the eVinci TEM reactor to adapt to different needs and energy policies. High efficiency is a final standout feature. Because it operates at high temperatures, the eVinci TM reactor achieves greater thermal efficiency than conventional reactors, making it ideal not just for electricity generation, but also for industrial applications. For example, it can produce the high temperatures required for hydrogen production, a clean fuel source expected to play a significant role in future energy systems. The reactor can also be used for district heating and other high-temperature industrial processes. These unique features position the eVinci TEM microreactor as a transformative energy solution. With passive safety systems, long operational life, fuel flexibility, and high efficiency, this reactor has the potential to address the energy needs of remote communities, industrial sites, and even contribute to sustainable energy transitions worldwide. While the eVinci TEM microreactor holds significant promise, there are several challenges that need to be addressed before it can be widely deployed. One major hurdle is regulation and licensing. Nuclear reactors require strict regulatory approval to ensure safety and environmental standards. But because the eVinci TM reactor is a new type of modular, transportable system, existing regulations don't always apply directly. Developing appropriate standards and licensing processes for microreactors is an ongoing task, requiring close collaboration between regulatory bodies, industry experts, and scientists. Economic factors also play a significant role in the development of the eVinci TM reactor. While microreactors offer many advantages, building and deploying them is a complex and costly process. To achieve commercialization, Westinghouse and other developers need to demonstrate that these reactors are not only safe but also economically viable for widespread use. The cost of initial development and the infrastructure needed for deployment can be a barrier, especially in countries with strict nuclear policies or high regulatory costs. Westinghouse has made strides in addressing these challenges. In October 2023, they launched a new design and manufacturing facility near Pittsburgh dedicated to accelerating the eVinci TEM microreactor's commercialization. This facility will focus on engineering, testing, licensing operations, and prototype trials to streamline the development process and ensure that the reactor meets safety and regulatory requirements. Another major step forward is Westinghouse's collaboration with the U.S. Department of Energy through the Front Engineering and Experiment Design FEED contract. This partnership supports the development of a test reactor at Idaho National Laboratory, which will help finalize design, test safety protocols, and gather data to aid in the licensing process. These efforts aim to address technical challenges and lay the groundwork for commercial deployment. As these projects progress, the eVinci TIM microreactor is closer to becoming a viable energy solution for remote, industrial, and emergency power applications. Overcoming the regulatory and economic barriers will be crucial, but with continued support and investment, this technology could soon play an essential role in sustainable energy systems worldwide. The eVinci TIM microreactor represents an exciting leap forward in clean and reliable energy technology. With its compact, transportable design, passive safety features, and flexible fuel options, this reactor could provide a sustainable energy solution for areas where traditional power infrastructure is not feasible. By meeting the needs of remote communities, industrial sites, and emergency response zones, the eVinci TIM microreactor could play a critical role in building a resilient, low-carbon energy future. Despite the promise, challenges remain from regulatory approval to economic viability. But with ongoing testing and partnerships, including efforts at the Idaho National Laboratory, Westinghouse is making steady progress toward bringing this next-generation technology to market. As advancements continue, the eVinci TEM reactor could soon be deployed to power isolated regions, support industrial operations, and contribute to global sustainability goals. If you're interested in the future of clean energy and innovations like the eVinci TM microreactor, make sure to subscribe to our channel. Give this video a thumbs up and share it with others who are curious about sustainable energy solutions. Join us as we explore technologies that could change the world and lead us toward a cleaner, more resilient energy future.